everyone, welcome back. We're going to continue our investigation of solving logarithms, and we're going to actually use logarithms to be able to find exponents for our problems. So today our learning target is explaining how those exponential and logarithm functions are related. We're going to be able to evaluate logarithms and use the laws of logarithms to simplify our expressions and our equations today. We're going to be able to go from exponential to logarithms. We're going to be able to simplify those equations and be able to solve those equations and make that connection between laws of exponents and laws of logarithms. So let's kind of get started on some problems and some talking here. So let's start off when it comes to what we're actually doing on these problems for today. So for today, we're going to see problems where we're going to have like a to the x equals b. So ultimately you get some number raised to the x equaling b, and we need to figure out what our x is. X is what our variable is. So we're going to have a problem and we have to figure out what the exponent is. So right now we don't have really a good method of figuring out what our exponent is. But if we think back to last week when we were talking about those properties of logarithms, we know that under the power property of logarithms, we can actually take that exponent and we can bring that exponent out to the front, right? So in order to do that, though, we first need to have a logarithm. So in any equation, when it comes to mathematics, as long as you do something to both sides, you have not changed the equation. So I'm going to start by taking the logarithm of both sides. So that would give me log a to the x equals log of b, right? So then I can sit there and I still want to get that x all by itself, and my x is still up in that exponent. So if we remember our power property of logarithms, I'm run out of room. That states that whatever is our exponent or our power, we can actually bring that out to the front of our logarithm. So I can now rewrite this by bringing x out to the front. X times log a equals log b, right? So my ultimate goal was still to figure out what x is. So I still need to get x here all by itself. So this is just x times the log of a equals log of b. So if I want to get x all by itself, I can divide both sides by log a, right? So then on the left, I'm just left with x, right? Log a over log a, those are going to cancel each other out or be 1, equals log b over log a. And then ultimately, once we get into numbers, you're just going to kind of plug that into your calculator and it's going to give you a number. So let's actually try it, an example out and see how we do. So they want us to solve for x. So let's say we have 6 to the x equals 1/6. So ultimately, I want to solve for x, which is up in my exponent. And right now, I'm looking at this going, I don't know what it could be because I don't know what to do with my x up in the exponent or up in the power. So I want to get that out. So I know that in order to get that out, I have to use my property of logs, the power property of logs. So the first thing I'm going to do is take the log of both sides, right? So I'd have log of 6x equals the log of 1/6, right? So then now under that power property, I know that my x can come out to the front. So then I would have x times log of 6 equals log of 1/6. My ultimate goal is to figure out what x is, so I need to get x all by itself. So in order to get x all by itself, this is really just x times log 6, right? Log 6 is just a number. So in order to get x all by itself, I'm going to divide both sides by log 6. Divide by log of 6. So what am I going to do? I'm going to get x equals log over 6 over log of 6 is going to be 1. They're going to cancel each other out. And then I'm going to have log of 1/6 divided by log of 6. And we can plug that into our calculator because we know where our log button is. And if we plug that into our calculator, we will get x equals -1. And that's your final answer. So let's spice it up a little bit and try another one. So for example number 2, let's say they give us 2 to the 2x equals 64. So I want to know what my x has got to be in order for 2 raised to the 2 times x is going to give me 64. So again, because my variable is up in my exponent, I need to get that out of there. And in order to get it out of there, I need to use my power property of logarithms. So the first thing I need to do is take the log of both sides. So the log of 2 to the 2x equals log of 64. Now using my power property, I know that whatever is in my exponent or my power, I can bring out to the front. So then now I would have 2x log of 2 equals log of 64. So again, my ultimate goal is to figure out what x equals. So I need to get x all by itself. So we can either do this in one step or in 2 steps. If we want to do it in one step, this is 2 times x times the log of 2. So if I want to get x all by itself, I need to get rid of the 2 and I need to get rid of the log 2, right? So since they're all being multiplied, I know that I can go through and I can divide by 2 log 2. And if I do it to one side, I have to do it to the other side, right? 2 over 2 is 1. Log of 2 over 2 is 1. So I'm left with x on this side equals log 64 divided by 2 log of 2. So ultimately, we're going to plug this into our calculator. We have to be smarter than the technology we use. I always say this. And sometimes the way, if we plug all of this into our calculator might read this as log of 64 divided by 2, and then all of it times log 2. So I always make sure that when my denominator has more than one operation going on it, I sit there and throw some parentheses around there, right? And then if I plug this into my calculator, I'm going to get x equals 3. And I can even check it if I go up here and if I put in 3, 2 to the 2 times 3 equals 64. So we want to know if 2 to the 6th equals 64, right? And I kind of break this down into 2 squared times 2 squared times 2 squared equals 64, right? So 4 times 4 times 4 equals 64. 4 times 4 is 16, times 4 is 64. 16 times 4 is 64 equals 64. Cha-ching, we did it right. Sometimes these take a little bit of practice to get used to them. The biggest part is to always remember that like log of 64, that is one number. That is not 2 different things that are going on. That is one number. It's just a way that we write the number. Good luck. I'll talk to you guys soon. Bye.